Hello guys, welcome back to the channel. Today we'll be solving LeetCode 11 container with most water. This question is from 2 pointers in blind 75 question. It is a medium question. So let's begin this question without any further delay. So here's the question. You are given an integer array height of length n. There are n vertical lines drawn such that the endpoints of the ith line are I0 and I height I. Find two lines that together with an x-axis from a container such that the container contains most water. Return the maximum amount of water a container can store. Notice that you may not slant the water. So what we have to find is basically we have these. So let's imagine this is a base. We have this imaginary line of different heights. We have to find two heights such that the container can store more water. What does container storing more water means? Basically means if we are finding the how much water can be stored, we have to multiply with this length and this height, because it is going to be storing this much water. So basically we have to calculate this is length and this is the height. Since we cannot slant it, what does slanting means is if this and these are the two lines, you cannot slant in a way that the water will be stored like this. So this is not, you cannot do that. You can only fill up this much water. So the basically water, how much water you can store is, if this is left and this is right, it is given by r minus l. The distance is given by r minus l, which is multiplied by minimum of between height l and height r. Because even if the right height is long, if the left height is less, you cannot store the maximum amount of water. You can only store up to this limit. So this is how you can calculate the amount of water. So, but what we want is maximum amount of water. So in a brute force sense, what we can do, let's move this image over here. So in a brute force sense, what we can do is if we have an array, so what we can do is take this as a left and take this as a right, have stored array as max comma formula that we have. So because we have formulated a formula, and for every L loop for R, loop again for R, which means that in this first condition the left is the first and the right is basically L plus 1. So it means that there will be two for loops, one loops for left which will be changed every times the right goes to the end condition, and another for loop which will increase the right. So it will be the time complexity will be O n square, because we are using two for loops and we are going to twice for them. We are counting the number twice. So this for loop will go this and this for loop will go number. So this will be O n square. So what we can do to make this minimum, since we are using basically we are using 2 pointers and using 2 for loop for each of the pointer, why don't we use the 2 pointer technique? So the two pointer technique basically is um, just like the using two for loops for each pointer. Use one for loop and change both condition. So basically means if for L in range height, uh, the left will be changed like every time here, but we have another condition that changes R as well. So we can use this technique. So but how can we use this technique to find this answer? Let's look at the image again. So what we can do is keep a left pointer over here and keep a right pointer over here. Since we'll be how can we get the maximum value? Maximum value is having maximum distance. So we are using left pointer on the leftmost side and the right pointer on the rightmost side, and another is max value or greater value in heights. So this is how we can find the maximum result. So what we can do is we keep changing the left and right according to the max higher value that we get. So which basically means is if height left is greater than height right, so we already found the left which is higher in this case, so maybe we can find the right also as an higher. So what we can do is we reduce the R. Why we reduce the R? I will explain. So like in another condition we increase the L. So I will explain the both of the condition. So in this case we have R value is higher than the left value. So why do we increase the L value? Because and in while doing this we're also calculating like result and like doing max and like result and using the formula. So we are keeping store of result here, but we are changing the left value and R value in a sense that we may find another value. We may find another left value which is greater than the older left value, or if we reach here we may find another right here which can give more result, which increases our chances of finding the maximum result. So we move our left pointer here in this case and we store the value which is I think this is the answer. So increases changes the answer to 49. So this is the left value. We will not be changing the left value because left value is higher than right value, so we change the right value. Right goes here, so it's again the left value is greater than right value. Right goes here. So this is the tricky part. So you may ask like why is not, like since we have found both left and right, why is not this an answer? And it is because we are not looking for higher left or right value. We are looking for the maximum amount of water. Yes, it is true that left and right condition, the height of left and right condition is important, but we are missing out the fact that the distance, the base distance is also important. While getting the result, the base distance is less than in this case, so this is not our answer. And we will be like continue this case until the left value and right value are not equal. We don't want to be like left value is here and right value. No, we don't want, because we have already checked this and this case, so we don't want that. So this is an algorithm of finding the maximum amount of water. So, and yeah, we are not slanting the container. We are not using like this. We are using the minimum value of left or right, height of left or right. um, we are not slanting anything, so I think we are all set with this algorithm. So now let's go to the coding session and see how it goes. So here we are with the coding session. We'll be using Python to solve this problem, but before starting writing code, let's write out the algorithm what we discussed. So use two pointers, one on leftmost, one on rightmost. Change the left and the right according to their heights. So this is basically the algorithm. So let's give a result of -1 because there might be an empty array or something. So let's keep it as a -1. So left pointer will be 0, right pointer will be at len heights -1, and we'll be looping while r is less than while left pointer is less than right pointer. So we'll be calculating the result with the maximum of result comma minimum of left and r multiplied by r minus l. So we have already discussed why the result is this condition. So if height of left is greater than height of right. So in this, so what will it be in this condition? If left is then r will decrease, else left will increase, and we return result. Okay, let's try running the solution. Of course there's a typo, height, and sorry I forgot, minimum of height should be the case, not just left and right pointer. We are comparing the height, not the pointer. Then let's run. Again, and it got accepted, and let's submit it. And yeah, it beats 87.28 of users within Python, so it is pretty much faster than other solution, which basically means brute force solution using ON square, but this is faster in ON. So yeah, this was for today, guys. Thank you guys for watching the video. If you like the video, give a like, comment if you have any other ideas of how you can solve the problem. And I'm making this video to make a better understanding of data structure and LeetCode problems. So if I have missed anything, please let me know in the comment sections, and please subscribe my channel for other LeetCode and data structure videos. Thank you.